All right, so that's kind of where we're at. So today, we're going to do goal number 1, 2, and 3 here, solve and graph compound inequalities involving and ors. Goal number 2, we're going to write solutions in interval notation. Okay, I'll remind you what that looks like. We have done some basic inequalities earlier this year. And then last but not least, I'm going to talk about intersections and unions of two sets. All right, so back in the day, a little warm up, we'll just do this together. We did this early on. I think like in chapters 1 or 2, we did a little of this stuff. I have x is greater than -3. Okay, so some reminders. If I do less than or greater than, okay, that's when we use our parentheses. All right, when I'm doing less than or equal to, greater than or equal to, that's when we use our brackets. That means it's inclusive. Okay, so on my number line, I'm going to put -3 here. And I have greater than. I have my variable x is greater than -3. That greater than sign is like an arrow pointing me towards which way to shade. So that greater than is pointing to the right. So it's greater than, so it's a parenthesis, and then I'm shading to the right. So that's what my shading looks like. And you'll have to do that via my math lab, but it'll be easy. Okay, it might even be a multiple choice question where you have to match up which graph it should be. And now when we do interval notation, we just write what we see from left to right. We don't see it, we don't see it, we don't see it. Ooh, I see it right there. I see it on -3. There's a parenthesis around that, and it's shaded, and when does it stop? Does it ever stop? Goes all the way to infinity. That's called interval notation. So I have -3 to infinity parentheses around that.
And infinities can't be brackets, right?
Infinities will always be parentheses. Good question. All right. So part B, I see I've got x is less than or equal to 2. So that less than sign is like an arrow pointing to the left. Also, less than looks like the letter L, so it's going left. So I always say parenthesis or bracket left or right at 2. What do you guys say? Shout it out.
Bracket.
It's a bracket to the arrows pointing to the left. So bracket to the left. So what numbers are way over here on the left-hand side? Those are the negative numbers on the left, right? So it goes from -infinity, and it goes right to, it stops right there at 2. So bracket on 2. So final answer for interval notation is parenthesis, -infinity, comma 2 bracket. Okay, and that's just a basic inequality, right? And now we're going to work on ands and ors. Okay, so ands and ors. Does anybody have questions on example warm-up number 1, A or B there? Are we okay with that? So now we have an and. Okay, so solve and graph x is greater than -3 and x is less than or equal to 2. So here is -3. I'm going to put -3 over here. And then we say parenthesis or bracket left or right there. Parenthesis or bracket?
Parentheses.
Left or right?
Right.
To the right. So this thing is shaded to the right. Awesome. Then we do the next one. 2. We know 2 is on this side, right? So 2's over here. So that's half the battle, is making sure you put your negatives on the left and positives on the right on a basic number line. And that is a bracket, I heard, to the left. Okay. So what I'm trying to do is I'm trying to see where the blue and this fuchsia pink meet. All right, so that's an and, is where the overlap is happening. And in this case, the overlap happens all in between, right? So my interval notation right underneath here, I don't have a ton of room, but I'll write it. I have parenthesis, -3, and it goes all the way to 2 bracket. So that's how you write it. So I look from left to right, I don't see it, don't see it, don't see it. Ooh, I see it at -3. And then it's shaded all the way to 2 bracket. And then that's it. That's an and. Okay, you guys have any questions with example 1? So that's the new stuff, is just putting them together. Easy peasy, lemon squeezy. So we look at number 2. So solving graph, this guy have 2 is less than 4 minus x, which is less than 7. Okay, now this, anytime they're smooshed together like this, there's like 2 inequalities here. This is an and. If you want to, you could cover up this less than 7 here and write it like this. I do not do this, but you could do this. You could write this one, 2 is less than 4 minus x, and cover up that inequality, I get 4 minus x is less than 7. You could do that. Okay, I don't, but you could. Okay, so if you want to separate it, go for it. What I usually do is I think of this as 3 columns here. Okay, there's 3 parts. And whatever you do to one part, you have to do to all 3 parts. Okay, so like over here, the first thing I would do, I would subtract the 4 over, right? I would subtract 4. Well, that's what I would do over here as well, right? I would subtract 4. So I just go ahead and do that here. And if I do it to the 2, I've got to do it to the 7 also. You have to do it to everybody. All right? So if you bring in donuts, if this was non-COVID, if I brought in donuts, I couldn't just bring in donuts for Riley, or I couldn't just bring donuts in for Jimmy, all right? I'd have to bring in donuts for everybody. So if I subtract 4 over here, I've got to do it to everybody, okay? So then I simplify. 2 minus 4 is negative 2. The 4's here cancel, leaves me with less than negative x. And 7 minus 4, so less than 7 minus 4 is 3. Okay, so far so good?
Yes.
So again, you could solve these if you want, totally fine. Or we got to solve this one. Now again, I'm trying to solve for x here. Trying to solve for x. So what's the last thing I got to do to get this x by itself? So this is like negative 1 times x. Anybody at home suggestions on what to do? Kai, Taylor, Mariana, Riley, Jasmine, Destiny, Eddie? What do you guys think? How do I get this x by itself? Any ideas, y'all? Anybody in class? Suggestions? No, not add. How do I get the negative away from it? What if it was 2x? What would you do if it was 2x?
Take away 2x? Just the 2?
Mm-hmm. Good guess. What do you do with the numbers in front of x's? How do you get rid of them? That's negative 1 times x. Yeah, I divide over. I divide over. Divide over. Okay? So I end up with negative 2 divided by negative 1 is 2. This turns into x. And 3 divided by negative 1 is negative 3. Now, does anybody remember what we have to do when we divide by negative with inequalities? Yeah, so these less thans are now going to be greater than. We have to flip our signs. Okay, so I'm going to highlight this idea here. Okay. We'll star up here. Anytime you multiply or divide by a negative, we got to flip our signs.
Multiply 2? Or that was just divide?
Multiply or divide, yep. So if you had like negative 1/2 and you had to multiply both sides by negative 2, you have to flip your signs. So anytime you multiply or divide, you got to flip your signs. Okay. All right, now, this one had a lot going on here, okay? And I don't really love how this one is written, okay? You see how the 2's on this side and the negative 3's on this side?
Yeah.
What I can do is I can flip this whole thing around now. I can rewrite it. So I can rewrite this and put the negative 3 here and the 2 here and the x in the middle. And now look at your alligator. The alligator is eating the 2, so it should be eating the 2 when I flip it all around. And the alligator is eating the x. So these greater than signs are now less than signs again. Okay? So final answer is this. Well, this is an and, so here's negative 3. Here's 2. And then this is an and. Ands are shaded in between. So thumbs in. They're going to shade towards each other. So it's going to be a parenthesis because they're not equal to. And they're going to be shaded in between negative 3 and 2. Okay. And if you want to look at it, is x less than 2? Yep. Here's 2. Less than is to the left. If I rewrite this one, x is greater than negative 3. If I read it this way, x is greater than negative 3, for sure. Works out perfect. Questions, y'all? Okay. The other option is, again, rewrite them like this. Some people like to do this. They're able to follow that easier. You can do that. Totally fine. Okay. Interval notation again, from left to right, negative 3 to 2, parentheses around them. So from left to right, Michael, negative 3 to 2, parentheses around. What's that, bud?
Greater and less than both those, they go directly.
So they flip here.
Yeah. And they
Yep.
flip over there.
Now, when I take the negative 3 and I flip-flop them, the same thing happens. I take these greater than signs and they have to be flip-flopped. That way, when I'm looking at this, this first inequality, I have 2 is greater than x. The alligator's eating the 2. The alligator's got to be eating the 2 over here. Okay. Over here, the alligator's eating the x versus the negative 3. The alligator's eating the x. Okay, so when you flip, I just flip-flop these, because usually it's low number, high number. Low number, high number. Okay, so we want the negatives on the left and the positives on the right. That way it looks like a number line. When you have to do that, it ends up flipping your inequality sign. So you flip basically the whole thing around. Okay, great question. So it was originally less than, now they're greater than. And when I rewrite it one last time, it becomes less than again. Okay. Typically, it's low number, high number, x's in the middle, and then less than signs when you see a smooshed together and compound inequality. All right. Do we have any other questions? Great question. I can always show you another one of those if you'd like at the end. Okay. Plus, we have my math lab to check it out. Okay. I want to try to give you guys some my math lab time. So I got one more here, I think, right? Just one more example for these, and then we got the sets. So example 3. This time I have graph and solve these guys. Why it says pH there? That must be a typo or something, so I can scribble that out. So I have 3x minus 6 is less than or equal to negative 9, or 3x plus 5 is greater than or equal to 20. Okay? So I'm going to solve each one of these individually. So let's do this one first. First one. Okay, so the first thing I'm going to do, I'll add the 6 over. So I've got 3x is less than or equal to negative 9 plus 6 is negative 3. And now what's my last step?
Take away the 3, divide.
Yeah, so 3 times x, the opposite of that is divide. So I'm going to divide by 3.
And then you flip.
So I've got x is now less than or equal to negative 1. I divided by a positive, so I don't need to change that at all. I don't need to change the inequality sign.
Oh, wait, why?
What's that?
Why? Oh, wait, never mind.
I just divided by a positive, so I don't need to change it.
If it was negative 3,
It was a negative 3x, so I'd have to change it. Very good. Okay. So I take a look at the next one. I've got 3x plus 5 is greater than or equal to 20. I'll put that here. So first thing I got to do, how do I get this x by itself? Alana, what can I do here? How do I get this x by itself? I got 3x plus 5 is greater than or equal to 20. Subtract, did you say 5? Like that. We get 3x is greater than or equal to 20 minus 5, we know is 15. And then what's my last step? Division. Divide by 3, boom. And we get x is greater than or equal to 5. Okay. So now it's time to graph them. So let's graph x is less than or equal to -1. Here's -1. Parenthesis or bracket left to right. What do you guys say? Shout it out. People at home, shout it out. People in class. Bracket to the left. So I got a bracket. It's less than to the left. And then 5 is on this side. So here's 5. And I say parenthesis or bracket left and right. X is greater than or equal to 5. Bracket because it's equal to. Boom. To the right. To the right, to the right. Everything shaded to the right. Interval notation, last but not least, guys, when we're all done with this. I look from left to right. What do I see like you're reading a book? Well, it's shaded way over here. What type of numbers are way over here? Yeah, negative infinities. So that's negative infinity to -1, bracket. Okay. And then this one, don't see anything, don't see anything. Ooh, I see something right at 5. So bracket on 5. And it goes all the way up, 5, 6, 7, 8, all the way to infinity. Okay? So the last thing you're going to see is a new symbol, and that's U. So in between, you're going to see U, which means union. Okay? And we'll talk about that here in a second. U, or union, is another way for or. So union, if two people get married, they're in a union. So what's yours is mine, right? So this one or that one. Okay? So that's a union. That's another word for or. All right. Do you guys have any questions with that? So pretty easy stuff, right? Just ands and ors. The tough one is this one, but this one had a lot of stuff going on because there's a negative that we divided by, and you got to flip it around, but really not too bad. Okay? So let's finish up with goal number 3, unless you have questions. Does anybody have questions out there in Zoom land and Zoom land? People in class, any questions what we're doing? All right, let's finish up. We got 6 quick examples. Easy peasy, I promise. All right, so we got some new terminology here, okay, when we're talking about sets. Okay, so it says here, A and B, I have big sets here, right? Think Venn diagrams. You guys have done Venn diagrams before, right? It says A and B are sets, and we're talking about an intersection of A and B is denoted as A. It looks like an upside down U, kind of like an N. All right. So A intersection B is how that's written. And that consists of what is overlapped right here. Okay. So if I have 2 Venn diagrams, A and B is overlapping, that is the intersection of A and B. That's kind of like and, right? That's like the and. And then the last one is union. We just saw that symbol. When we're talking about union of 2 sets, that's AUB, looks like that, is the set consisting of all of the elements belonging to A or B or both. So anything that's in A, anything that's in B, or both. Okay, that's our or we just talked about. Just basically putting them together. Okay. Well, sometimes you're looking for ands, you're looking for the intersection of 2 sets, and they have nothing in common. Okay, so if they have nothing in common, so that means the intersection of A and B is the empty set or the null set. You guys seen the circle with the slash through it? Then it's what we call disjoint.
Uh-oh.
That's called disjoint. It's kind of like if a mom and dad don't have anything in common anymore, they get disjointed or they get divorced, like my mom and dad did. Tear. I'm over it though. 40 years. It took me, 30 years to get over it, but I'm okay now. I promise. Not gonna cry. All right. So that's disjoint, when two things don't have anything in common. All right. So we take a look. They're going to give you guys different sets. Okay. So A is even integers. Okay. So I want you to think even integers, nice, pretty numbers. 2, 4, 6, 8. Who do we appreciate? B is odd integers. So think 1, 3, 5, 7, 9, ... Okay. C is the set of numbers 2, 3, 4, 5. And D is the set 2, 4, 7, 8, and 9. Well, what they want us to do is take a look at these sets and look for the intersection. So A intersection C here. All right, so again, A is even numbers. And C is 2, 3, 4, 5. So I'm going to write out A, just a few of numbers here. So 2, 4, 6, 8, ... And I'm going to do the intersection with C. C over here is 2, 3, 4, and 5. Well, if I take a look, what do they have in common, y'all? What is the overlap? What is the things that they have in common? 2 and 4, that's it, right? So 2 and 4. 2 and 4 is my final answer.
Could it keep going if it wanted to?
For A?
Yeah.
It could, yeah, but I just listed as many as we needed. Set C is only to 5, so really could have stopped at 6. So 2 and 4 are intersections. And guys, those fancy brackets for me are next to the P in your laptop. So you might have something that you can plug in. So I have 2 and 4 as my answer. A lot of these questions on my math lab are multiple guess or multiple choice. Okay?
It's hard to draw.
They are hard to draw. When I draw my fancy brackets, I go here to the middle and then middle here. And then this one, I do the same thing from the top to the middle. But if I go middle to the bottom, I get a really weird squiggle. So I go here to there. So from the bottom to the middle on the last one. Fancy brackets. Hard to make. All right, let's take a look at the next one. So again, I'm doing an intersection of B to C. So B is odd integers. So I'm going to just list out some odd integers. 1, 3, 5, 7, 9, ... And then the intersection with C. C is again 2, 3, 4, and 5. Now again, intersection is what they have in common. So what do you guys see that they have in common? 3 and 5. Again, this is me showing a lot of work, especially for notes. So they have 3 in common. This is 5. You guys show what you need to show. Again, it's all my math lab homework. But it's always nice when you're taking notes, is to, especially when you have a test and you can use these things. How are you coming up with those answers? So far, so good. All right, so the last one, example 6, I have C union D. So I go up here, here's C. C is 2, 3, 4, and 5. And union D, D is 2, 4, 7, 8, and 9. So 2, 4, 7, 8, and 9. Sorry, my paper was moving on me. So I have 2, 4, 7, 8, 9. So union means put them together. Okay, what's yours is mine. So we're going to make our own set of all these numbers. Now don't repeat. I repeat, don't repeat numbers. So you see how it's listed twice here, 2 and 2, just write it one time. And I always write them in order as I see them. So the next number numerically would be what, 3? And then 4. And then this guy has a 5. And D has a 7, 8, 9, so I got to include that. So 7, 8, and 9. So again, I'm just including every single number I see in those two sets as one big set now. Okay? So like, I don't know, this is all the possessions of person C, this is all the possessions of person D, well now it's all underneath one house, if that makes sense. It's all unionized. Okay? You guys want to do one more? Let's do example 9, just to finish up. So A intersection B, want to do this one for sure. A again is all even numbers, 2, 4, 6, 8, dot, dot, dot. Intersection with B. B is all odd numbers, odd integers, 1, 3, 5, 7, 9. What do they have in common?
No solution.
They have nothing in common. So I'm okay with the empty set, or my math lab, one of the choices will be the null set, the empty set. Another way to write the empty set is just two brackets that have nothing in there. They're empty. Okay, so that's the empty set. If that makes sense to you. Okay, so we'll skip the last two for you guys. All right, so ladies and gentlemen, do we have any questions with ands and ors? Set notation, are we okay with the set notation?